Dear students, in this video lecture, we are going to discuss about digital signals. What is digital signals? How we can measure the digital signals? How we are transmitting the digital signals? So those things we will discuss in this video. In classroom discussion topic, we are going to discuss about digital signals. So every lecture we are discussed about the outcomes. About this lecture outcome of this video lecture is, after listening to this video lecture, as a students, you will be understand about the digital signals and sketch the digital signals for the digital data. The digital data and digital signals. What is digital data? What is digital signals? How we can represent digital data and how it will be converted into the signals, that we will discuss in this lecture. So these are the content we are going to discuss in following slides: digital signals, bit rate, bit length, and transmission of digital signals. So digital signals. What is digital signals? So we know that already we are representing the analog signal using the sine waves. Okay. But information can also be represented by the digital signals. So we can represent through digital signals also. For example, 1 can be encoded as positive voltage and 0 is represented as the 0 voltage. Okay. So how we can represent it? The values, binary values, we know that that's the digital data. Digital data may be zeros and ones. So the 1 may be represented as the positive voltage and 0 is represented as the 0 voltage. Okay. So like this, we can represent the digital signal. For example, you know that signals, how we can represent. So already we know that this is the time and this is the amplitude. So normally we can represent. So for example, in this plus voltage, 0 voltage. Okay. So signal, we can say that this is the 1 value, means this is the positive voltage. It is a 0 voltage means 0, we can represent 0. Okay. So again 1, we can represent like this. So it can represent like this, 0, 1, 0, 1, like that we can represent the digital signals. A digital signal can have more than 2 levels. In this case, we can send more than 1 bit for each level. Okay. So how we can say that the level means the combinations of zeros and ones. For example, 2 levels means 0, 0 level, 0, 1 level, 1, 0 level, 1, 1 level. So it is for 2 bits. Okay. So like this we can represent. If in case 3 bit means, how many levels will come? If 2 bits means 2 power 2, 4 levels will come. In case 3 bit means 2 power 3. So 9 levels will come. How it will come? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, like that will go. 0, 0, it will start from 0, 0, 0, will end with 1, 1. So totally 9 values are there. Okay, we can represent the data like this. So the following figure will represent 2 signals. That means one with 2 levels and other with 4 levels. 2 levels and 4 levels. So 2 levels means, what is the 2 levels? Zeros and ones. 4 levels means 0, 0, 0, 1, 1, 0, 1, 1. These are the 4 levels. We send 1 bit per level in part of the figure and 2 bit per level in part of the B figure. So we will see the figure. If the next slide, the figure is there. So normally, if you want to find the level means, you can, each level needs log to L bits. Okay, how many bits required for levels? Log 2 of L bits. This is used for finding the levels. Okay, so bits. So how many bits are there? Means if you want to represent 2 levels means, what is the value? Log 2 L. So here L value is 2. So totally 1. 1 bit is required for representing 2 levels. Okay, in case 3 levels, anything is there? No, because 3 is the combinations. It's not power of 2. So always the level should be to the 2 power n. Okay, so 2 power n. N values are number of levels. So see here, this is a representation. The bit is 1 or 0 only. Only one bit we are representing. For that, representing one bit, we are using two levels. Okay. So 1 is positive voltage and 0 is the 0 voltage. Okay. So what is the bit rate? How many bits we are transmitted per seconds? Okay. So in this timeline, we'll start from 0 to this up to this point 1 second. So per second, how many bits we are transmitted? 2, 3, 4, 5, 6, 7, 8. So 8 bit per second. That is the bit rate. Okay. So here we are seeing like this 2, 4, 8. Sorry. 2, 4, 6, 8, 10, 12, 14, 16. So 16 bits will be transmitted in 1 second. So that's why we are saying 6 bits per second. This the data rate is 6 bits per second. Okay. So likewise, we can represent the digital signal. And how many levels we are required? If in case we want to represent 2 bits means we need 4 levels. Okay. Clear. So now you can calculate it. A digital signal has 8 levels. So they are saying that 8 levels. How many bits are required? We know the formula log 2 of n. What is the value? Log 2 of 8. So what is the value for that? 2q2. So 3 into log 2 of 2. So 3 into 1 equal to 3. So how many bits required? 3 bits required. Okay, per level 3 bits are required. In case of 8 means 3 bits required. So the next question, a digital signal has 9 levels. So level is 9. How many bits are needed per level? So how we can calculate it? Log 2 of 9 we can calculate. Okay. So when we are calculating what is the value we are getting, 3 point something we will get. Example 3.6 something we will take. Okay. So what is the value we are getting? 3.6. So there is no 3.6 values. So what we have to do, whenever we are getting this value, directly we will go for next value. So 4. So how many bits are required? 4 bits are required if in case of 9 levels are there. Okay. So next one bit rate. So now we know that most digital signals are non-periodic, and thus period and frequency are not appropriate characteristics. Okay. But in another term, bit rate means what is that? Instead of frequency, we are saying in analog signal we are using frequency, but here we are using bit rate. Okay. So in digital signal, what we are using? Bit rate. Bit rate means number of bits sent in 1 second. Okay. It may be represented as bits per second. Okay. So how many bits we are sent per second? That is unit of representing digital data. So here you will see this example. Actually, assume we need to download text document at the rate of 100 pages per second. What is the required bit rate of the channel? The channel will transmit how much, what is the bit rate, how much data it wants to send. So we have to calculate. So here you just take that 100 pages. Okay. So 100 pages is there. Each page, how many lines should be there? For example, you have to assume any number of lines. Okay. So for example, 25 lines I will take. Okay. So then each line, how many characters are there? If I will consider only 10 characters. For example. Okay. So how many pages, how many lines, each line, how many character is there, but each character, how many bits it will take. So normally one character it will take 8 bits. We will assume that. We are assuming 25 lines is there, each line 10 characters are there, then each character it will take 8 bits. So multiply of this entire value, that is the final results, bits per second we will take. Okay. What is the value it will get? Nearly 100 into 25, 2500. 2500 means next 10, so 25,000 into 8. So 25,000 means 2 lakhs. 2 lakhs bits per second we can use. This is the bit rate of this. So how we can represent like in kilo 200 into kilobits per second. Why? Because so these three lines will be 10 power 3. 10 power 3 means kilobits per second we are saying now. So normally we are saying 200 kilobits per seconds. Next one is bit length. What is bit length? So we discussed already wavelength for the analog signal. What is the wavelength? One signal, how much duration it will take. The same like this. Okay, like how much one cycle, how much time it will take. No, that is wavelength. So same like that bit length. What is the bit length? It's the same like the similar digital signal is bit length. Bit length is the distance one bit occupies on the transmission medium. Okay, how much time or how much duration it will take in the transmission medium, that is bit length. How we can calculate it? Bit length equal to propagation speed into bit duration. Okay. So now you see here, this is the time domain specification chart. Okay, this is the amplitude. So this is the time. So here they are, instead of frequency, what they are using? Bits per second. How many bits per second? Here one bit, here one bit, 2, 3, 4, 5. Sorry, 6 bits we are used. 1, 2, 3, 4, 5, 6. So 6 bits are there. But in the frequency, what is the frequency of this? So we don't know. It is non-periodic signal. Yes. So what is the value? How much value it is there? We can represent like this. Okay. The digital signal we represent like this. The bottom they are given like this, like time and frequency domain of non-periodic digital signals. Okay, periodic means we know what is the high voltage volt of this particular frequency data. But here it is varying, so we can represent like this. Okay, it is non-periodic signal representation. Now we must be discuss about the transmission of digital signals. So now we know how we are representing the signals, but what are the methods are there for transmitting the signals? So there is a baseband transmission signal, broadband transmission signal. Two types are there. The digital signal is a composite analog signal with an infinite bandwidth. Okay. So the baseband transmission and broadband transmission are there. Baseband transmission means sending a digital signal over a channel without changing the digital signal into the analog signal. Okay. Baseband means simply whatever we are convert the digital signal is there, no same signal we are transmitted. We are not converting digital signal to analog signal. Okay. That is baseband transmission. In baseband transmission, requires that we have a low pass channel. Okay. So with bandwidth that starts from 0. So you see here, this low pass channel means it's starting with 0. So wide bandwidth, it will be used for wide bandwidth. In case of we have dedicated medium, the bandwidth containing only one channel. Okay. So only one channel is dedicated bandwidth means what will be happen? The entire capacity. So this entire capacity will be used by only one channel. Okay. For example, the entire bandwidth of the cable connecting two computers is one single channel. Okay. So this channel fully occupied by the both the device. Here again narrow bandwidth. This is wide bandwidth. This is the narrow bandwidth. So the low pass channel will start with the 0. So we can represent digital signal in the frequency domain like this. Okay. The next one is the broadband transmission. Broadband transmission means it is the modulation. Okay, modulation. What is the meaning of modulation? changing the digital signal to an analog signal for transmission. We have to convert digital signal to analog signal, to analog signal, then we will transmit it. Okay. So modulation allows us to use band pass channel, a channel with a bandwidth that does not start from 0. So it is not starting with 0. It may be one frequency 1 and frequency 2. So already we know that, yes. What is the highest frequency in analog signal? We are checked. Highest frequency minus lowest frequency for bandwidth we are discussed. Okay. So here same like that. It is not from 0. It will start from any frequency. So how it will be converted? So input is the digital signal. So here the converter may be used for converting digital signal to analog signal. Okay. So this analog signal will be transmitted through this medium, that is baseband channel. Band pass channel is used for transmit. So this medium will transmit the analog signal. After reaching this analog signal, that will be converted into digital signal. That digital signal will be reached to the destination. Okay, so like this, the digital signal will convert it to analog will be converted to digital. There is a methods are there that we will discuss in the second unit. Okay, so now we are in end of this lecture. So now revisited the lecture outcome. What we have discussed, we must be know about what is digital signal. If I will give you any data, you are able to draw the digital signals as well as how it is transmitted, what is bit rate, what is bit length, those things we are discussed. So now you can sketch the digital signals for the given digital data. Okay. Some sample questions I given here. You just read carefully. A digitized voice channel. We are given one channel. As we will see in the chapter 4, we will discuss in later. Is made by digitizing the 4 kilohertz. Okay. So 4 kilohertz means what is the 4 kilohertz? 4 into 10 power 3 hertz. Okay. Bandwidth analog voice signal. We need to sample the signal at twice. 2 times we will take the sample. Okay. And we assume that each sample requires 8 bits. Okay. So what is the bit rate they are asking? So 4 into 1000. That is 4000 is the bandwidth voice signal. And twice we are taking the samples. And then total 8 bits for each samples. So 4 into 2, 8000, then 16,000 bits per second, or 16 kilobits per second. So this is the answer we can use it. Okay. So next, one second. So now what is the answer? You know that, yes. So next question. What is the bit rate for high definition TV, HD DV? So normally in television TV we are using high level pixels. Okay, high definition TV means what is the pixel rate normally we are using? So 1920, normally the pixel rate in the HDTV is 1920 into 1080. So normally we are using this bit length. So then what we have to think in each, how much pixel we are using? So in case 30 times per seconds, it will be renewed 30 times per seconds. We can assume this value. Okay. So how much time it will be renewed? So 30 times it will be renewed if you are taking like this. And then each bit, how much resolution it will take. So example, 24 bit is wants to represent the color pixel. Okay. So one color pixel wants to represent 24 bits. How much time it will take? It's renewed and resolutions. So we can multiply these values, then finally we will get it 1.5 Gbps. We can calculate it 1.49 something will come. So 1.5 gigabits per second is the bit rate of high definition TV, but the channel provider, they are compressing and reducing it 20 to 40 Mbps. Okay, but what is the capacity? 1.5 Gbps. Thank you very much for listening this. Any queries is there, you can ask in the classroom discussion. Next classroom discussion topic is transmission impairments that we will discuss in the next video. Thank you very much.